And again, my name is Chaz Karen. I am a trainer for Bosch. I've been with the company since 2003. My background prior to coming to Bosch was I worked in the LP gas industry, which is what brought me to this company was that experience. Prior to working in LP gas, I served with the United States Marine Corps as an artilleryman. And in these trying times, I have to kind of do a quick public service announcement. It's something very, very near and dear to my heart. If you have veteran friends that might be in isolation right now, reach out to them, give them a shout. You may not be aware, but every day in the United States prior to the current situation, 22 veterans commit suicide, and that's every single day. Um, and right now with the social isolation, it's very hard on some veterans. I actually have a much older than me veteran, an Army veteran, who just a week and a half ago was committed for a 30-day psychiatric evaluation based on just not taking care of himself and being isolated. So reach out to those people if you have some friends that are in that situation. They will be happy to hear from you, I'm sure of it. And with that said, we'll get on to today's presentation. What we want to talk about are our electric tankless water heaters, or electric water heaters in general, because we do have some mini tanks. So we'll talk about this product lineup, some specifics about the product, some stuff on servicing and that kind of stuff. So talk about quick overview. We're just going to do a quick refresher on what it means to use electricity as the source of power for heating water. Again, as we generally talk about gas as our source of power, it's a little bit interesting to talk about what's happening with electricity. Bosch mini tanks, that's our Tronic 3000T series, the lineup, what they are, how we're going to put them in, the components and some service components of that. Then we'll talk about the Tronic 3000C, that's our tankless point of use electric products, what the lineup looks like, how do we put them in, and some of the component details on the inside. And then we'll talk about the whole house, high output, high capacity 6000 series, and that lineup of the models there, how we install them, the components, and we'll talk a bit about troubleshooting for this product as well. And we will have plenty of time for a wrap up. This is a little bit shorter than some of my gas presentations. We'll probably be less than 40 minutes on this presentation. So we'll have plenty of time for any questions. And you can shoot them again into that chat box or the Q&A. Don't chat directly to me, chat to all panelists because Elaine will be compiling questions as you put them in. Don't send them directly to me, and we'll more efficiently get through the questions that way. Again, with this presentation, hopefully it's informative and does you some good and that kind of stuff, but it is no replacement for the IOM. That installation manual is going to give you all the details you truly need for a successful installation. If you would like to take a look at a manual before buying a product, absolutely, you can go to our website, Bosch Heating and Cooling, heatingandcooling.com. At that website, you can download all of our current installation manuals, manuals for retired products, service bulletins, engineering submittal sheets, and even some of the marketing type materials there are downloadable. And that's all going to come to you as a PDF. You don't need to sign up for anything. There's no membership or anything to access that stuff. It's open and accessible to you. If you are in the field and you're in front of a unit and you're having some issues, our tech support line's there to help you out. 800-283-3787. Give those guys a shout and they can help you out when you're in front of a unit. Help you resolve whatever issues you're having. So electricity, when we think about electricity as a source of power, I mean, we think about electricity as a powerful source of energy, an efficient source of energy. We think a lot of things about electricity, and we can talk about large services coming into a home and what all that means. But the reality is when we talk about electricity, what we're really talking about is wattage. That's what we're really concerned with, what's going on there. And the relationship between a watt, or in this case, a kilowatt in BTUs, is there's 3,412 BTUs per kilowatt of power, or 3413 if you'd like to listen to my friend Dave Fayock. He's pretty positive it's 3413. In any rate, watts are going to be equal to your voltage times your amperage. So that's why we get a lot more power out of a 240 volt product than we do out of a 120 volt product, because the voltage times the amperage is what's defining your kilowatts. All of our stuff, with the exception of the mini tanks and one of the point of use products, are based on receiving 240 volt electricity. And why do I bring that up? Because it's very important when we talk about what happens if we do have a voltage drop. So in theory, that 240 volt produces 18.5 or draws 18.75 amps. But if the voltage drops to 220, now we're going to talk about only producing 100 or 4,125 watts of power versus the original 4.5 kilowatts or 4,500 watts of power. And again, when we think of watts, we often say that without actually really defining it. We're talking about kilowatt hours, so kilowatts per hour, and that's the same thing with BTUs. We talk about burners and BTUs, but we really mean BTUs per hour. So it's the same thing here. Then it even gets worse when we talk about what is that derated performance. We're derating about 8%, a little over 8% when we talk about that drop. So if a product was maybe able to produce a flow rate of 1 gallon a minute at satisfied temperature, when we lose that 8%, now we're only able to produce just over 3/4 of a gallon of water at a particular set point temperature. So it is a significant derating, and it happens just like that. Then also we could talk about it, hey, what if it gets really bad? We drop to 208 volts. Drop to 208 volts, that product that was doing 4,500 watts is now only doing 3,900 watts, and that derating is now down to approximately just a little over 13% derated. So it's very, very significant when we talk about what's happening with power draw and ensuring that the voltage is correct. So one of the things we talk about in something that can trap you in electric if you don't pay attention to it and pay attention to it potentially prior to doing the installation is confirm the voltage, make sure that the product is actually going to do what the product's rated to do, that the voltage is available. Another thing that can always get us is water. So we talk about temperature rise, how cold is the water coming in versus how hot do you want it coming out? What kind of flow rate do you need to achieve? And what's happening with the water pressure inside of the home or the facility? And all of those things are going to come into play. And they come into play because we have an activation flow rate, how much water has to be moving through a product for the on-demand products, how much water has to be moving through that product in order for it to begin to energize. And we talk about flow governing and the idea of managing the flow. And we talk about all of our gas products being dynamically flow governed. The flow governing on the electric products is not dynamic, it's a static governing. And then the ability to modulate, whether we can alter the energy draw for a unit, whether we're talking about a maximum energy draw or a fixed energy draw. And in the case of the Tronic 3000T, it is a fixed energy draw. This is a mini tank, so it's thermostatically driven. It is not flow activated. There's no flow activation for this product. It's thermostatically activated. So it's a very, very simple product from that standpoint. Not a whole lot to concern us with that, with the exception of the fact that this product can run out of hot water. If we draw the tank down and it's full of cold water, we're only going to deliver cold water. 3 models in the Tronic 3000T series. We have the ES 2.5, which is nominally 2.5 gallon product, then the ES4 and the ES8, which is nominally an 8-gallon model. They have a full 6-year warranty, 2 years on parts, and the relief valve is included. Relief valve is always going to point up or on the top side of the cabinet is where we want to see that relief valve. Their thermostat is adjustable, and that's going to be right through the face of the unit, so it's very, very user-friendly from that standpoint. We do have dielectric tappings, so we're trying to drive down galvanic corrosion or any chance for galvanic corrosion. Mounting these products, they do come with a bracket. The intended is that the bracket will shoot to the wall, and then we hang the unit on the hook. They're also flat on the bottom, though, if you want to put them on a shelf or something. The housing itself is a polymer, so that it doesn't rust up, it doesn't get that corroded look that a typical mini tank gets sitting in the corner of a filling station restroom. Mount these on the wall where they don't get hit by the mops or anything like that, and they're going to last a lot longer. Very easy plug-in 120 volt connections on the 2.5 and a 4 gallon size. The 8 does require hard wiring. And you'll notice here on this table that the 2.5 and the 4 are the same dimensions vertically and horizontally. Difference being how deep is the product from the wall going from the 2.5 to the 4 gallon size. Physically, the ES 8 gallon size is significantly larger. You'll also notice here that they all have the same element, a 1440 watt element. So it's the same element for all of these products. Efficiency sits the same on all of them. Rating plate gives you your model number and also the serial number for that particular product. That's something you're going to need that information if you ever have to call into tech support so that they can help you out. Just be ready to provide tech support with that information. Physically, it looks like this, and this would be for the 2.5 and the 4 gallon size. Cold water's on the right, hot water's on the left. We know that's kind of a plumbing convention. We don't want that backwards because then our dip tube won't work. Relief valve sits on top, and then there's the power switch, which is integrated with the thermostat there. With the cover popped off, we can now see our element is also 4-bolt. It's a 4-bolt element, which also incorporates our anode rod. The tank itself, which we can't see here, but it is a steel glass line tank. And the thermostat control there is on the right-hand side. Again, the power switch, there's an internal reset. The thermostat's internal, obviously the temperature adjustment knob is internal. And then that element is replaceable. The anode rod is serviceable. Again, 4 bolts or 4 nuts to remove that electrode set. And it looks just like this. Up across the top there, we have the sacrificial anode rod, and then that V-shaped or U-shaped, however we want to describe it, electrode set there. Electrode, anode, again, serviceable. We can take that thing out. T&P is included. And there is a dip tube, so again, we don't want to plumb the cold into the hot. We're going to have very, very poor performance, and that does happen sometimes. We want to make sure that we're plumbing these things correctly. We need to make sure that we're again supplying a significant or a large enough service to actually satisfy these products. ES8, we're talking about a 20 amp circuit. All of them we're talking about a 20 amp circuit. Why? Because they're all the same element. That's the bracket. That's what the bracket looks like. That bracket needs to shoot or screw into something solid. We don't want that in sheetrock or anything. It needs to hit a stud or something like that. And then, of course, the alternative is if there's a shelf or a vanity or something like that. They are flat on the bottom. They will just sit on a shelf like a conventional mini tank. ES8 is unique in that it ships from the factory with the water on connections on the right-hand side, electrical connection on the right-hand side. We can rotate this 90 degrees counterclockwise. Then we'll have to see the brass plug on the right-hand side. The brass plug goes to where the relief valve currently is, and then the relief valve has to go to where the brass plug is, and then we can orient this with the cold in, hot out pointing upwards. So that's a quick rundown of what's going on with those mini tanks. They are very, very simple products, very easy to use products, and can create comfort for people in a lot easier way. The Tronic 3000 series is going through a revision right now. I'm going to show you the features of the new revision, which was supposed to be out already. Unfortunately, the current situation has pushed it back a couple months at least. We're now projecting probably July for the new product range. They will share the same model numbers though. So we have within this point of use electric tankless 3 model numbers, US3, US7, and US9. Those are the 3 model numbers that we talk about. And what are the advantages of these? They're very, very small. They're significantly smaller than the mini tanks. Copper heat exchanger, 5-year warranty on the copper heat exchanger. Thermal cutouts to protect the unit as well as protect the consumer from getting hurt, from getting burned. We have adjustable configurations for the different models where we can actually increase or well, technically decrease their performance. Tappings, 1/2-inch tappings, and again, we can go multiple positions with the new range, which will be hitting us in July. The current range, the connections have to be down or to the right. Advantage for these products is you got a remote sink. You do not need to plumb hot water to it. You plumb just cold water and you produce the hot water at that point versus wasting the energy of flushing out a line, purging out a line to get hot water to a remote location. And the other advantage being they don't run out. So whereas a mini tank, you draw enough water through it, it will run out of hot water. The tankless electrics will not run out of hot water as long as the energy is being supplied to and their flow rate through them is at the activation flow rate or higher, they're going to produce hot water. So point of use, that's the big advantage of what's going on with these products. The thing about these though, they really only want to plumb to a single sink. Why do they only want to plumb to a single sink? Mini tanks, we can plumb to multiple sinks and we just end up running out of hot water. With these products, they do not modulate their energy input. They're either energized or they're not energized. They only have 2 positions there. So with that condition, imagine that if we plumbed it to 2 sinks and we sized it for 2 sinks. So you have both sinks on and it's making hot water that's adequate for those sinks. If one of the sinks shuts off, now what happens is the temperature rise doubles because the unit does not have the ability to derate itself. They'll look identical on the inside, with the exception that you can see the US3 is 120 volt versus the US7 and US9 are 240. Again, mounted underneath the sink in a vanity, very, very small, still gives you access to the vanity. If we had a mini tank in there, that space would be entirely used up. Activation flow rates are going to depend on the particular model where the activation, how much water has to be flowing through it in order for it to turn on. Cold water in, hot water out, just that simple. The new range of products is going to allow us to have the water connections left, right, vertically up or vertically down. And again, that should be hitting us sometime in July is where it looks like they're going to hit us now here in the US. All of these have that model and serial number, little sticker on the side of the cabinet, gives you model and serial number. If you need to call tech support, make sure you have that information available. So we got the loop there. It's a copper loop that's a heat exchanger. Inside that heat exchanger, there's a pair of elements. Cold water comes in, power comes into the terminal block. Thermal cutout protects the unit and protects people. Power indicator tells you if it is receiving energy or if it is energized. And then this flow switch is what actually activates the unit and will allow us to produce hot water. Physically like this, cold water enters, goes to the flow switch, continues around, the flow switch moves. The flow switch moves, energizes the element, and it begins to produce hot water. So that's physically what's happening. It is a physical flow switch that's energizing that. It is not an impeller. It is not sensing the actual flow. It is simply sensing that there is flow and that flow is above the activation flow rate. Element's energized, coiled inside the heat exchanger. Interesting to note, it is a copper sheathed element, so it is protected from any contaminants in the water, or reasonably protected from any contaminants in the water. And the heat exchanger itself is copper tubing. On the 7 and the 9, you have a high and a low setting. So we can actually, it ships on the high setting. On the low setting, what happens is we then energize just one element. We don't energize both elements, we only energize one element, effectively making it two different SKUs. Although it's all one piece, it can actually perform in two different settings. Simple screw, you slide the screw to the low setting and we get 50% performance. And it's just as simple as this. It just pushes one of the contacts away for the second element. So when it energizes within the high position, the contacts energize both elements. When in the low position, it never touches that other contact. It never energizes that second contact. And this would be the performance difference. So you see the US3 single position. It is not adjustable. It is just a single element anyway. US7, we talk about it performance-wise between 6.1 and 7.2 on high, and that's going to depend on whether it's getting 220 or 240 volt. And then on the low, it'll be 3 to 3.6 kilowatts. US9, we see the same thing. And then on the US9, we're also showing you what the performance would be if we put it in a commercial situation with 208 volt. It actually drops down to a 7.1 kilowatt appliance, or 3.5 in the low position. Then as we notice the activation flow rates, 3/4 of a gallon moving through it, that's the activation point, and we can see the temperature rise. So the US9 will give us on the high position 84 degree temperature rise. So if we got 50 degree water coming in, that's going to give us 134 degree water coming out at 3/4 of a gallon per minute. And again, because it can't modulate, as we push to those higher flow rates, the temperature rise will drift off every time. Wire sizes, US7, US3, 10, US9, we need 8-gauge wire. TCO, manual reset, be aware of that. That's why we never want to feed these things preheated water, because it is a manual reset situation. So if we feed preheated water, it shoots over the limit. It has to be manually reset. So just be very aware of that. No preheated water. We really only want to have these flowing to a single sink. If we have them flowing to multiple sinks, you'll get performance that will be variable performance depending on what the actual flow rate is through the unit. And again, we can look at those flow rates and what happens there as we move the flow rate, what happens to the unit. Which brings us to our whole house products. The whole house products, great performance, really interesting products when we talk about them. as far as for what they can do. Very small, considerably smaller, obviously, than an electric storage tank. And typically, so now we can talk about doing showering, laundry, and that kind of stuff with these products. With the point of view stuff or the mini tanks, it's not going to happen. So the models are the 6000 CWH27, 6000 CWH17. You look at the capacities on the 27, 4 gallons a minute at a 45-degree rise, pretty much something that you would only talk about maybe in southern Florida or maybe down along the Gulf Coast or something, where a 45-degree rise becomes something that's a valuable number. And then take this into account. 27 kilowatts times 3412 BTUs per kilowatt puts us at approximately 92,000 BTUs, the capacity of this product. And if you think about that in context of where we look for gas products, we typically talk about gas products being in the range between maybe 150,000 BTUs as a low to 199,000 BTUs or even higher potentially. These products are relatively low power compared to the gas products, and that 17 is only about 58,000 BTUs. So very low capacities here. Just be aware of that. If people with multiple bathrooms or something like that may not be happy with this product. Again, we don't want to feed preheated water into these things. We want to just feed them groundwater temperature. That's really what they want to say is a best application. And as we look at the temperature rise required and then the flow rate capacity, if we want to talk about a 70-degree rise, that's going to assume that we want 140-degree water in the water, or 120, check that, 120-degree water, and it's coming in at 50 degrees, 1.7 gallons per minute with a WH17, 2.6 gallons per minute with a WH27. So we can see pretty clearly that WH17 really belongs in southern climates where we don't need more than a 60-degree temperature rise. So we're going to assume that the water wants to come in, at 60 degrees to get to 120. 27, yeah, we can go into just about anywhere in the US and still be able to produce a flow rate that will satisfy a shower, but it's only going to satisfy a single shower at a time. This graphic kind of gives you an idea of where we would say each product makes most sense. Again, a sticker on the cabinet. That sticker is going to define the model and serial number. Important information if you ever need to call in for support on this product or for registering warranty and all that kind of stuff. 2 thermal cutouts protect this unit. So there's actually 2 heat exchangers, the left-hand canister, right-hand canister, and they each have their own TCO. And again, these TCOs are manual reset. So again, the reason why we don't want to feed these things preheated water. They'll operate on 240, that's where they're rated at, but they will operate on 208 or 220 as well. Again, reduced performance. Connections for these include the WH17 needs 2 40 amp 2-pole breakers. So that's 4 spaces out of the panel just to supply the electrical requirements to the WH17. WH27 requires 3 40 amp 2-pole breakers, 6 spaces out of the panel, and a combined total draw of 120 amps. So we're going to recommend minimum, absolutely bare minimum of 150 amp service for the WH17 and the bare minimum of a 200 amp service for the WH27. Wiring is pretty straightforward. Breakers, 2 breakers or 3 breakers depending on the product. 8-gauge wire, 2 pairs coming over to the unit. Each breaker is going to go to its own L1 and L2, which sometimes gets a little confusing. We've seen that screwed up, particularly on the WH17, where the first breaker goes to each L1, the second breaker goes to each L2, which is incorrect. Each breaker gets its own L1 and L2, and depending 2 or 3. It is a little bit different when we talk about our friends up in Canada. Canada will not allow multiple breakers to feed a single appliance. So what we have to have is a single 80 amp or a single 120 amp breaker, and then this accessory piece here, which then allows that service to then split among the multiple wiring blocks inside the unit. Plumbing, it's designed for cold water only. Discharge side, yeah, we need to see copper or high pressure flex connections. That's not really a requirement of the unit. That's a requirement of code, so just be aware of that. Teflon tape and dope on the threads. Be really careful that we don't get any of that inside, which would jam up the impeller, which is clearly important. And we definitely don't want to sweat anything to this unit where we could potentially damage it. Hot water runs want to be as short as possible for obvious reasons. We don't want any added delay in delivering hot water to the fixtures, so we want it as close as possible. Then it should be steady water pressure. It's an important thing because as water pressure changes, flow changes through a fixture. As flow changes, then the unit has to modulate differently to accommodate that. And then it becomes the flow rate changes as it changes, then the unit has to respond to that. So the unit's always behind whatever the flow rate is. It cannot anticipate a change. It can only respond to a change. That's all it can do. So as we look at how the power looks, this is WH17. WH17 in each of the heat exchangers has two elements in each of the heat exchangers. You have the inner pair and the outer pair on both of the heat exchangers. To prove these elements, to make sure these elements are good, we're going to use our multi-tester, and we're going to ohm out, not just tone, but we need to actually get an ohm reading, because the copper sheathing, if we did just tone, if we went just for continuity, it's possible that the element could be bad and we're getting that continuity through the copper of the jacketing. So it's very important that we actually definitely want the ohm reading. And this is a cut and paste directly out of the installation manual. So this information is available anytime somebody might need to do service on one of these products. The information is available right there, ready to go. WH27 adds another element to each of the heat exchangers or each of the canisters. So we have the inner pair, the middle pair, and the outer pair. And again, the ohm readings for each of those. TCO, and this would be also true for the TCO on the point of view stuff. Just need to confirm that there is continuity through that as a safety. Temperature set point, 95 to 131 maximum water pressure, 150 psi, and then take note that the activation flow rate is 0.6 gallons per minute. So we do need to see that 0.6 gallons per minute for this thing to perform. Then we can see the derated output as we talk about 220 volt. We're only at 22.5, 22.5 kilowatts versus 27 kilowatts on the 27. And at 208 volt, we've dropped all the way down to 20 kilowatts. So just be very aware of that. And again, as we said, when we talk about electricity, confirm the voltage, make sure it's there for you. So troubleshooting this product, we do have a little bit of troubleshooting capability. The neon light, the indicator if the unit's energized, neon light's off. Make sure there's enough flow going through the unit to activate the unit. And if it's a new installation, make sure there's not a plumbing crossover, which is drawing off some of the flow from the unit so that it's not hitting activation flow rate. Take the cover off. The transducer is housed on a clear housing. Check and make sure the impeller is actually turning. Make sure that we didn't get some dope or some kind of gunk inside of there that has wedged the impeller so that it's not turning. We can actually see that. We can physically observe that. And make sure that it's getting power. Make sure the breakers are on. Make sure that, that it is, in fact, getting power. Make sure that neither of the TCOs have tripped. Obviously, if the TCO is tripped, that's going to put us in a bad situation there. So make sure that that's good as well. Make sure that the voltage is there. You know, it was originally installed with 240 volt. Now something's happened. More houses are on that same transformer or something like that. Maybe the voltage has dropped off, and now the people aren't getting the performance they were previously getting. Make sure that we have that. Another thing that can impact it if the voltage is too low, if the water temperature is very, very low. You installed the product in July with very warm water temperatures, and now come December that people think that it's not working correctly. It's possible that's just based on the water temperature drop. Make sure again that the breakers are on. It is possible that an element has failed, and we looked at how we're going to confirm that an element is good. We're just going to ohm that element out on the correct pairing and make sure that the power is there for you. The light's on and it's not performing, water's not hot enough. Again, make sure that all the power is on, make sure all the elements are good, make sure none of the TCOs have tripped, make sure the temperature is actually set to the position where people want it, make sure that it actually is trying to make as hot a water as people would like to see. And then check and see if the water flow is too high. If the water flow is too high, people can obviously manage that at the fixture, or you can manage it for them by putting in a flow setter or before the unit so that we can't not allow more cold water in than what it can produce to hot water. Again, new installation, check for that plumbing crossover. Fluctuating temperatures. What's a likely thing to cause fluctuating temperatures? One of the biggest things is that we have fluctuating water pressure. Fluctuating water pressure, again, will alter the flow through the fixture. So one of the best things that you can do to manage that for people, and what causes fluctuating pressures, where you get regularly fluctuating pressures. One of the common things, particularly as we talk about well systems, is a well trawl tank that is waterlogged or not pressurized enough. Those kind of things can happen, or maybe undersized. Maybe all of those things are correct or something. In order to maintain steady pressure inside the house, if on the discharge of the well trawl, on the outlet side of that, on the house side of the well trawl, if you put in a pressure reducing valve and set that pressure reducing valve at the lower limit, or maybe just a little bit above the lower limit of the well pump, what you will do is create a situation where inside the house you have very, very stable pressure, because the pressure on the tank side is always above the pressure on the house side. So that fluctuating water pressure, if we do that, it's going to be a great answer to managing that for your customer and making a more comfortable situation. Other things that can do that are maybe a shower body that's gone bad or something like that, and it's manually changing the water flow, and the consumer's not trying to change the water flow, but that happens. So we can take a look at that too. And that's really what I got for you on the electric products. It's not a whole bunch, but more than happy to open up to any questions that anyone might have at this point, and we'll take care of you there. And I do appreciate your